In case of volcanic stratigraphy, the base and the top of the eruptive units are to be identified. Here we are dealing with volcanic rocks in layers, and to distinguish different layers we need to find out its base, of course, and its top. How to identify the base or the top? In case of volcanic stratigraphy, we have three types of unconformities. New nomenclature is coming ahead, which we do not see in the usual chapters of unconformities in the textbooks in sedimentology and in structural geology. First one, we call it minor unconformity. Here the word minor means a much smaller time gap, and if you look at the definition given here, how much is the time gap, that is not precisely stated. When we see the moderate unconformities, there a time range is given. So, the minor unconformity will be of lower time range. For example, in case of the moderate unconformity, we have hundreds or thousands of years of break in the volcanic eruption as recorded in the layered volcanic rocks. So, here for minor unconformities, the time gap between the lower and the upper units will be less than hundreds of years. Smaller the gap, more difficult will be to identify in the field. So, minor unconformity establishing in the field may prove difficult. In other words, the minor unconformities are indicative of which are separated by short periods of response or between different pulses of the same eruption. There is same eruption going on, there can be very short break in between, and we call that as the intra-eruption. Now, we come to the definition of the moderate unconformity. As I told earlier, these are indicative of hundreds or thousands of years of break in the volcanic rock record. They can be the product of erosion of previous volcanic deposits during long response periods, which means a volcanic eruption has happened and then for a long time erosion has taken place, and after that another phase of eruption happened and the lava flow has taken place. And on these moderate unconformities, we may find reworked materials or paleosols or paleosoils that can develop. Since there is a long time gap, the erosion has happened and then it was exposed to atmosphere for a long time, reworking of material and paleosols can develop. Even though it indicates a longer time gap of hundreds or thousands of years of break, it may not indicate a change in the dynamics of the volcanic system. So, hundreds or thousands of years time gap revealed in the volcanic rocks may not indicate a change in the dynamics of the volcanic system. Now, we come to the major unconformity. As we saw, when we were using the word minor, it indicates smallest time gap. When we use the word moderate, it indicates a bigger time gap, and when finally we use the word major, it indicates a still bigger time gap, and this time gap will be more than few thousands of years. Now, major unconformity formation is related to the volcano and some changes that take place. Let us see what are they. They are produced either during the construction of the central volcanic edifice or stratovolcano. I am going to explain stratovolcano, the basic definition afterward, and sometimes the major unconformity are related to the collapsed calderas. Simply speaking, say this is a volcano and from here the eruption has happened. This portion after eruption may sink down and this is known as the collapse. Now, this collapsed calderas can occur instantaneously when the lava flow is happening, lava is erupted, or it can be followed by reactivation of volcanism. And in case of major unconformity, we may find non-volcanic deposits such as the debris avalanche, and different types of breccias can develop. What is the meaning of breccia? Angular rock fragments. We see the word breccia also in structural geology. When the faulted blocks move apart each other, they may break angular rock fragments, and that is also called breccia in structural geology. So, there tectonics is a reason, and here in case of these kinds of breccias, volcanism is a reason of its generation. Now, note that the volcanic stratigraphy cannot explain the inter-eruptive phenomena. Inter-eruptive phenomena, what does this mean? Between two eruptions, whatever happens is the inter-eruptive phenomena. That means phenomena happening between two eruptions from the same volcano. So, the debris flow and the lahars that form cannot be explained from the perspective of the volcanic stratigraphy, from the perspective of the three unconformities that I have mentioned. Now, if we look at the literature, there are several other nomenclature of unconformity in the volcanic stratigraphy, but those are terrain specific, depends on the local geology. If you search, you can find out Indonesian stratigraphic code where they are using different terms. Stratovolcano, it is a volcano constructed by alternate layers of lava flow and pyroclastic rocks. These stratovolcanoes are steep conical in form. Now, I come to the definition of the collapse caldera. So, here we say collapse of coherent floor bound by steeply dipping fault. There are three types. There can be plate or piston collapse, where this is the mouth from where the volcanic material moved up. As the molten material moved up, the base can sink. So, this kind of collapse is called plate or piston collapse, as if a piston is moving from top towards bottom. Now, there is another kind of subsidence that happens in calderas, the trapdoor subsidence. It is bound by incomplete arcuate faults. So, these are some of the incomplete and arcuate means curved faults that has activated, and the molten material has gone down over here. So, this surface is going to collapse. There is a third variety that is called the piecement collapse. I have drawn basically a graben geometry, and several normal faults have been drawn. Clearly, there are two deep directions of the two sets of faults. This is one set and this is the second set. For set 1, the deep direction is towards the left hand side, and for set 2, the deep direction of the fault is towards the right hand side. They are normal faults, and sinking happens. Typically, a graben geometry is produced. Note that a graben can be produced tectonically, but in this case no tectonic extension is happening, only the material which was here earlier has been removed, and therefore sinking is happening. And in case of tectonic grabens, tectonic extension is the key reason. This kind of tectonic extension has not happened in case of the piecement collapse. We are going to see the concepts in stratigraphy which are of historical relevance and the development of the subject. At the same time, I am not going to run through the detailed history of development of the subject, only the main issues will be looked at. Interestingly, many of the earlier geoscientists, geologists and the stratigraphers were not by training geologists. For example, take the case of James Hutton, who was a physician. He recognized the cycle of weathering, erosion and transportation by running water. Now we know that not just running water, there are also transportation done by glaciers or wind. So, whatever they recognized are having historical relevance, and the geoscience and stratigraphy has gone far ahead than these statements. Nevertheless, some of these statements are interesting and shows how the subject developed with time. Hutton recognized geological time, and he recognized an enormous time has passed on the earth. It is not few thousands of years or few tens of thousands of years, not millions of years, it can be several billion years. In recent time, we are using this phrase deep time as if there is a deep well, and from the top we are trying to see where is the base or the bottom, and the bottom is probably not visible. The next very important stratigraphic work comes from William Smith, who was by training a civil engineer. On the road construction site, he looked at different stratigraphic sections and he was able to prepare the first stratigraphic section. William Smith, being a civil engineer, must have studied elementary geoscientific issues, and William Smith might be doing the work when James Hutton's theory was established, and few other nascent geoscientific concepts might be available. The next important development, we can look at Charles Lyell 1797. Interestingly, his year of birth is same as the year of death of James Hutton. So, this means when Charles Lyell was studying geoscience in a primitive format, he was aware certainly about James Hutton's work and also William Smith's work. A very interesting statement is made from Charles Lyell's work, is that present is key to the past. By the way, this was not said by Charles Lyell, but this phrase, very famous one, was coined by Geikie in the year 1882. This principle, present is the key to the past, which I am going to explain, is also known as the principle of uniformitarianism. Let us look at it in detail. Curious people have always wondered how giant piles of sediments are produced. We do not see in our lifetime giant piles of sediments, kilometer thick sedimentary layers to be produced. So, ancient flood as described in Bible, in the Hindu text, and in many of the tribal communities, oral tradition was conceptualized. What it means, in the past there was a giant flood, enormous amount of sediments came and the sediments got deposited, producing huge sedimentary pile. Now, such concepts were challenged in the statement present is key to the past. The point is, at present we do not see any giant flood. In last few hundred years there is no such giant flood, and all over the earth there was covered by water. Instead, geoscientists in those days tried to think in terms of the present day processes, and they made a point that huge sedimentary deposits do not need giant flood to develop. So, what can give rise to that? The geological processes which we see at present, such as erosion and deposition, might have happened in the past, but over a very, very long time, not just few years, few thousand years, maybe for millions of years, and the earth may be as old as few billions of years. So, for a very long time, if a process is acting very slowly, effectively it can produce huge amount of sediment deposition. So, the earth was conceptualized in terms of a dynamic planet, or we can call it as dynamic earth. At present, when we are looking at a mountain, in my lifetime there is no visible change, but a human lifespan is very small compared to the geological time. So, if one takes into account of the geological time, many changes are happening on mountain, hill, plateau, in the river, in the oceans, everywhere in the desert changes are happening. So, over a very long time span, our planet can be called as a dynamic planet, or we can call it as a dynamic earth. These concepts are intrinsic when we say that the geological processes have been acting for a very long time, and that has cumulatively produced giant sediment deposition. Now, once this statement is made, it does not mean that all geological processes are slow. If we think, and from our common experience we can say landslides or avalanches happen much faster. Maybe 1 meter of displacement of loose material of earth can happen within 20 seconds. So, it is much fast process. So, we have to be careful while we say present is key to the past, we should not generalize it too much. As a corollary of present as key to the past, we can say if we study the past rock record, we can comment about the present, and extrapolating the concept, we can say that by studying the present day geoscience, we might be able to comment what is the future geoscientific outcome. For example, looking at the present day plate tectonics, geoscientists have commented future plate configurations, or how plates will move in future. In future, where the basins will be produced, where the new ocean can be produced, which ocean is closing down, etc. And if we link present with future, now we can say by studying the past, geoscientists can be able to comment about the future. This is also a generalized view. Let us take examples of exceptions of the statement present is key to the past. Let us take the case of plate tectonics. Now, with the present knowledge, we know that the Archean plate tectonics was markedly different from the present day plate tectonics. Several billion years ago, when Archean was persisting, plates were moving a bit haphazardly, they were jostling together, and the rate of movement of the plate was very fast because the earth was hot. So, the asthenosphere was moving with faster convection, and now at present the plate movement rate has been reduced significantly. We can put a rate, let us say 5 centimeter per year at present plate movement rate. If we look at the present day plate movement based on the GPS studies, we cannot and we must not extrapolate these rates for the past plate tectonics. So, in this way present is not a key of the past, not everything can be correlated. The rate typically has changed. Now, we will take example of some rock formation, for example, the banded iron formation, also known as the banded ironstone formation, which in short is known as BIF, and we will see what we learned from the past record of the banded iron formation, and with the present knowledge we understand we cannot say that the present is key to the past or past is key to the present. This is not going to work. This is just one example. There are many more examples that can be set that goes against the uniformitarianism principle. What is a banded iron formation? As it is stated in the first word banded, the rock is layered. Several layers or bands are there. These bands can consist of hematite or magnetite. Hematite is Fe2O3, magnetite is Fe3O4, and Q stands for quartzite, or it can be chert. That is what I am saying. In BIF, banded iron formation, there are alternate layers of iron oxide and chert, and there can be millions of microscopic bands, very thin band, or the bands can be thick few centimeter and which can be visible with naked eye in the field. So, here I am giving an example, hematite quartzite alteration within a banded hematite quartzite. Two types of BIF we can think readily, banded hematite quartzite and banded magnetite quartzite. Now, the point is these banded iron formation are mostly older than 1800 million year. We do not have a huge deposit of banded iron formation which formed 500 years back or 5000 years back or 20,000 years back. What is the reason that the banded iron formation developed such early in the earth history, and why it is not forming at the present? Why the present is not key to the past? Why studying the past banded iron formation we cannot expect same things happening on the earth? Let us explain. We know that when earth was formed, we had an anoxic atmosphere. Due to volcanic eruptions, there was SO2, CO2 and other toxic gases present on the earth, and there was no oxygen. That is the meaning of the word anoxic atmosphere or anoxic environment. Now, from the present study we know that iron readily dissolves in water without oxygen. So what we understand is that in the past, when there was an anoxic atmosphere, iron got easily or readily dissolved in water. Next, the important point is, even today there is in oxygen poor water in the Red Sea, in the sea floor we are finding iron is enriched 5000 times above the normal level. So, iron dissolution needs an anoxic environment. From here we understand very important statement that the Archean ocean must have contained dissolved iron and silica in an anoxic environment. This is all about the dissolution of iron. What about the deposition of iron oxide? To deposit iron oxide, we need chemical reactions, which I am not writing here, that requires oxygen. An oxygenated environment is required. So, to develop iron oxide in bands in banded iron formation which happened in the past, we need either regular or episodic oxygen influx. If there are episodic oxygen influx, then there will be episodic layers of iron oxides. So, what is the most likely hypothesis at present? There was seasonal change in sunlight, and along with bacterial action and mineral deposition, layer after layer alternately iron oxide was deposited. So, at present we have an oxic atmosphere. Plants developed over geological time, and the anoxic atmosphere altered to an oxic atmosphere where oxygen came into existence. Interestingly, the banded iron formation reached its peak around 2500 million year. This is also the Archean Proterozoic boundary. And after this 2500 million year, worldwide the BIF production declined, but it did not become zero. There were occasional bursts of banded iron formation, but rarely in the geological history, but certainly not in last few thousand years. Now, when we say that the banded iron formation was restricted mainly in the past many millions of years back, it does not mean that iron minerals did not deposit at all. For example, the banded iron formation is developed, and then rusting of that iron mineral, of those iron minerals such as hematite and magnetite, did produce red beds, and we know red beds as old as around 2300 million year back. So, 2500 million year back we had a peak of development of banded iron formation, and 2300 million year back rusting of iron has happened, and the rusted material got transported and got deposited, forming the red colored beds. Interestingly, this 2300 million year is also known as the Great Oxidation Event. This means the oxygen content in the atmosphere increased significantly. So, this marks a significant shift from anoxic environment to the oxic environment, from anoxic atmosphere to an oxic atmospheric condition, and 2300 million year and the younging direction till the present, the chance of banded iron formation got tremendously reduced. As I was telling, the rusting of iron is reported as old as 2300 million year back. There are sideritic mudstones which are iron bearing mud that were deposited in the Jurassic time. So, iron still got deposited either as rusted material or along with mud, but then it was not a typical banded iron formation. Charles Lyell's principle, present is key to the past. The two facts, plate tectonics, rate of movement of the plates have changed, and genesis of certain rocks have altered. There are other exceptions. For example, if you look at the evolution of plants and animals, many plants and animals got extinct over the course of geological time. Now, those extinct animals cannot be found living in the present. So, in that case, present is not key of the past. Moving ahead with different other views of historical importance, Hutton also thought about the internal heat of the earth, and he said that it is completely responsible for the earth processes. What is internal heat? When the earth was formed, it was very hot, partially molten, and then it has cooled down with time. Heat is still preserved, and that internal heat is still responsible for the earth processes. This is again partially true, not completely correct. We can think of various earth processes that are controlled by, let us say, the meteorite impact. Those are not related with the earth's internal heat. For example, a meteorite and can change the topography locally, it can produce giant depression. So, in that way it can change the topography. Example, the Lonar crater in Maharashtra, India. So, in this case the topography created, the crater created has nothing to do with the earth's internal heat. So, we cannot say whatever we see on the earth, everything is produced due to the internal heat. And with time, our idea of this concept of internal heat of the earth has also got refined, and many details have come up. Now, we say that the internal heat can be looked in several ways. There are concentration of the radioactive minerals in the earth's crust and mantle, whose decay produces significant heat. Now, we are going to see the Neptunist concept. This was given by Werner, 1749 to 1817 was the life of Werner, and Neptunist view says that all rocks, This means sedimentary, igneous and metamorphic. It starts like that, but then it excludes the recent volcanic lavas. They were produced from the chemical or mechanical deposits in a universal ocean. Now, this is also not correct if we look with the present day knowledge. Let us try to understand. Once we say all rocks except recent volcanic lavas, we mean all sedimentary rocks, and in igneous rocks we can take the plutonic igneous rock and the hypabasal igneous rocks and the metamorphic rocks. Now, once we say that by chemical and mechanical deposition in a universal ocean, this means that once the sedimentary rocks got deposited, they might get metamorphosed. In the universal ocean, suppose the sedimentary rocks got deposited, then they might get metamorphosed. So, that takes care of the metamorphic rocks. These rocks might get molten. So, possibly the Neptunist view says that the igneous rocks can also come from the sedimentary rock by melting. Now, this is again a simplistic view. Okay, what about the chemical and mechanical deposits? Chemical deposition, let us take the deposition of limestone, or mechanical deposits. What does this mean? Clastic sedimentary rocks. Example, sandstone, let us take mudstone, or let us take conglomerate, etc. The Neptunist concept says that all rocks deposited in a universal ocean, and that means all sedimentary deposits are marine deposits. As a corollary, as per the Neptunist view, all sedimentary deposits are marine deposits. Now, this is certainly wrong. We know there are many kinds of non-marine deposits. The example can be lake deposition, then there can be glacial deposits. This need not always be in the ocean. So, the entire gamut of non-marine deposits goes against the Neptunist view. The Neptunist concept, if deposition happens in a universal ocean, the concept will be helpful to correlate rocks from one place to another. Correlation of rocks far away would be possible. In the Neptunist concept also came the concept of facies, and this facies concept was not easily accepted at that time. It took a long time for geoscientists to understand. Sedimentation in a basin can be cyclic or rhythmic. What it means? If I get an alteration A, B, A, B, A, B in this kind of Younging direction, and the sediments are altering, we call it as a cyclic or rhythmic alteration. Consider this cycle A, B and C. In this case A, B, C, A, B, C, this becomes a cyclic repetition of the sedimentary units. Now, such cyclic sedimentation has frequently been found from rocks of diverse ages from Proterozoic up to Pleistocene. So, one such alteration is sandstone shell alteration, sandstone shell layer, or coal shell alteration. Now, there are two broad processes we can think that leads to cyclic sedimentation pattern. One is known as the autocyclic process. What is that? It is a process which is internal to a sedimentary basin, and it is independent of external influences. Let us try to understand what is the meaning of internal and external in this case. I give a very specific example here of repeated landslide in the marine environment, and there can be other cases also. So, this is a basin and this is the land part. Now, from the land part, imagine this material, rock material got slided down and got deposited in the basin. So, before that happened, there was sedimentation within the basin. So, this black layer indicates the marine sediments, but over there this landslided material 1 came into picture, and after that again for thousands of years, or maybe at least for hundreds of years, the marine sediment got deposited. So, you can see an alteration has happened. If this black portion I call as rock K, then K has come, the slide 2 has taken place. So, slide 2 will take away these materials and will deposit over here. That can be 1 and 2 may be of same composition in some case, think ideally. So, this got deposited. Again the marine sediments will be deposited. It may be possible that the marine sediments are compositionally the same and that got deposited. So, what I get from bottom towards top is K 1 and then again K 2 and then again K. 1 and 2 can be of same composition. So, I will write them as 1, it becomes K 1, K 1 and K. So, this is a case of cyclic deposition. Now, this process was internal. Sediments which were depositing from this place, of course, it came from some other source, but the deposition happened from here and the landslide was happening in the shore area. Far away from this basin and far away from the source nothing came. Now, in contrast, we will see the allocyclic process. Here the process is not internal and rather the process is external. An example of such a cyclic deposition can be global sea level change related repetition of sedimentary layers. Now, the global sea level change, transgression or regression happens not because of local geology, the local sediments, local influx of materials, local landslides, etc. This rather happens due to Earth's rotational change that in very large scale globally leads to change. So, the allocyclic processes deposits repeated sediments that will be global and which leads to a good chance that the allocyclic sediments can be correlated from one basin to another basin which may be far away. Not in all cases, but in some cases it may be possible. So, global correlation may be possible. Now, in comparison to this, if I look into the autocyclic processes, since it is local or internal to the sedimentary system, we may not be able to correlate globally the autocyclic depositions.